Hi, welcome to my tutorial on doing raster analysis using ArcMap. Let's see what we are learning today. At first, we will learn about some information and characteristics about the raster data. Then, we will solve some real-world problems using ArcMap. So, without further ado, let's get started. In its simplest form, a raster consists of matrix of cells or pixels organized into rows and columns or a grid where each cell contains a value representing information such as temperature. Rasters are digital aerial photographs, imagery from satellites, digital pictures, or even scanned maps. In raster datasets, each cell, which is also known as a pixel, has a value. The cell values represent the phenomenon portrayed by the raster dataset, such as a category, magnitude, height, or spectral value. The category could be a land use class such as grassland, forest, or road. A magnitude might represent gravity, noise pollution, or percent rainfall. Height could represent surface elevation above mean sea level, which can be used to derive slope, aspect, watershed properties. Spectral values are used in satellite imagery and aerial photography to represent light reflectance and color. Cell values can be either positive or negative, integer or floating point. Integer values are best used to represent categorical or discrete data, and floating point values are represent continuous surfaces. The dimension of the cells can be as large or small as needed to represent the surface conveyed by the raster dataset and the features within the surface, such as square kilometer, square foot, or even square centimeter. The cell size determines how coarse or fine the patterns of or features in the raster will appear. The smaller the cell size, the smoother or more detailed the raster will be. However, the greater the number of cells, the longer it will take to process, and it will increase the demand for storage space. Now, let's solve some real-world raster analysis related problems. The problem statement is shown here. The situation is described and then the questions are given. As the first question, we have to make a map with FFWC category. Let's jump into ArcMap and solve it. Let's import the given layers. As the water level is given in tabular form, I am using display XY data option to show the points in specific positions. Then I exported it as a layer to make it a separate entity. As we have a DEM of the ground level, we also must have the DEM of the water level. For that, let's interpolate the water level data and make it a raster. As we have some fault lines, we must use the IDW tool. Here we must consider that we are doing this for doing some calculation with the DEM layer. So we must make the necessary settings so that we can do the analysis in correct way. Setting the cell size to 300, setting processing extent as same as the DEM layer, setting the mask as the DEM layer, and running the tool will give us the water level DEM. Now, if we subtract the land surface DEM from the water level DEM, we get flood level. Now, I am doing that with Raster Calculator. This is the flood level raster, setting the symbology of the layer to match the FFWG water level. Now, as shown in the previous tutorial, I am making a map and this is the answer to the question number 1. Now, let's solve the second question, which asks us to make a statistic for the flood levels. Using the count field, we can calculate the area. We know that 1 pixel is 300 by 300, so the area will be 300 into 300. So we can calculate area for each type of flood. This is the answer to the question number 2. Now, for the question number 3, we have to convert the raster into a polygon using raster to polygon tool and then use the identity tool. Now, after recalculating the area, we can get it inside Excel and make pivot table to show the necessary table. This is the answer to question number 3. For question number 4, we can use the data-driven maps tool and set up the parameters to automate the creation process of the maps for each of the thanas. In data-driven page setup, we have to enable it. We have to specify correct data frame, layer and field. Then if we export it as a PDF and select all pages for export, we get all the maps in one PDF. This is the answer to the question number 5. I hope you learned something new today. Thank you for watching. See you in the next tutorial.